Okay, so today we're going to be looking at um, perimeter and area, but this time with similar figures. So again, similar figures, they're going to look similar, they're going to look a lot like this. So there are two figures that are the same shape, but they're different sizes. So this one is smaller than this one. So this trapezoid is smaller than this trapezoid. Okay, so for us to like compare the two areas and perimeters of similar figures, we need to use ratios. And here, this is telling us how scalar factors or ratios relate to the ratios of perimeter and areas. So this is saying if a scalar factor of two similar figures is A divided by B, or A over B, then one, the ratio of their perimeters is A over B, so it's the same scalar factor, the same as a scalar factor. And two, the ratio of their areas is A squared plus B squared. So let's look at this first question over here. This is saying we need to find the ratio smallest to largest of the perimeters, okay? So if I'm going to find the ratios of the perimeters, I'm going to be using the first point right over here. Okay, so I need to find the scalar factor from. So I just need to find the scalar factor from the smallest to biggest. So let me rewrite my formula here. A over B. And this is just to remind me of how to set up my ratio. So the smallest one is 6, and the biggest one is 9. Now, I could simplify these two. If I look carefully, I know that 6 and 9, they're both multiples of 3, actually. So I can divide both of them by 3. So 6 divided by 3, that's 2. 9 divided by 3 is 3. And now these two, they're not a common multiple of any number, just 1. But if I divide both sides by 1, I'm going to get the same number. So this is going to be the ratio for my perimeter. Now, let's scroll down. We have to find the ratio from smallest to largest of the areas. Now we're looking at areas. So we're going to use this second point right over here. The ratio of their areas is A squared over or divided by B squared. So let's write that formula just so we can remember it. So again, I'm going to have my smallest measurement, but this time I have that exponent, and the biggest measurement, but with also that exponent. So again, just like from last time, 6 squared, or 6 to the second power, it's the same as 6 times 6, which is 36. And 9 to the second power, that's the same as 9 times 9, which is 81. Okay? Now, for this over here, we could simplify this, right? So 36 and 81, well, if we think back, both of these are in the 9 times tables. So I can divide both of them by 9. So the way I'm like finding the greatest common factor with both of these is that I'm just thinking back to my times tables, what I know from it, from my 8 times tables, 9, 3, 1, all that. So that's how I'm finding out 9 is the greatest common factor between both of them. So if I do 36 divided by 9, I'm going to get 4. And if I do 81 divided by 9, I'm going to get 9. And this one is going to be this is now in simplest forms, because 4 and 9, it doesn't belong to any multiplication table. It's not a factor. It's not a multiple of anything. It's just 1. But if I divide both sides by 1, I'm going to get the same number. So this one is going to be my final answer, 4/9. Okay, and this was just a quick little video of how to find the ratios of areas and perimeters. We're starting off small so that we can work our way to more complex topics.